how to use carbon waste to make packaging, PET, or also sustainable aviation fuels, and what a brewery and bacteria have to do with it. That is something that Freya Burton from LanzaTech told me about in today's episode of Impactful Voices. Freya Burton is a senior leader at LanzaTech for almost 20 years. She has had roles spanning from R&D over communications to human resources, and currently she is leading global policy, external and government relations at LanzaTech. Freya also played an active role in the Jet Zero Council of the UK. And one thing I can tell you, she's also really good at making you excited about a technology that you might have not heard about before today. I definitely haven't, but now I'm a big fan of carbon recycling. So let's jump into it. Hi, Freya.
Hi, Leonie. Very nice to see you today.
Thank you, you too. How are you?
Doing very well, yes.
Thank you so much for joining us today and featuring on Impactful Voices. I told you before, I'm really excited. After Ulrike, you're the second female feature on this format, which is, of course, in an industry like aviation, a rare find. I maybe just want to hand over to you with asking you, I mean, LanzaTech is doing a lot more than aviation. So can you briefly tell us what your technology, your approach is?
Absolutely. So LanzaTech has developed a platform that essentially takes an assortment of different waste sources of carbon and converts that into ethanol, which sounds kind of like very kind of clean tech 1.0, and people might go, why do we need more ethanol? But really what we do is we enable the use of waste feedstocks. So it could be carbon that's locked in industrial emissions, so pollution. It could be carbon that's in trash, so municipal solid waste, or even carbon in biomass residues like agricultural residues and so on. And then the kind of the holy grail, as it were, is taking carbon out of CO2. So the whole goal of what we do is to kind of turn carbon from a liability into an opportunity, kind of give it another lease of life. And we do that by using a sort of biological process. We convert that carbon into ethanol, a bit like, I suppose you could think about it like a brewery, but instead of taking yeast and sugar to make beer or wine, we take carbon in a gas, so pollution or a gasified solid waste. We take a bacteria, which sounds weird, but it actually works. And that bacteria consumes the carbon, and as it grows, it replicates, it actually produces ethanol. And this becomes interesting because ethanol is this really cool building block that you can use not just, as a fuel blend in road transport, but you can also use it to make yarn. So, for example, you can turn it into synthetic fibers with downstream technology. So you can make a polyester yarn from recycled carbon, which is pretty cool. You can also turn it into packaging. Use it as an ingredient, for example, in cleaners, in fragrances. And then ultimately, it does have a lot of energy in it. And so we can actually convert that ethanol in a second stage process that we developed to drop in a sustainable aviation fuel. So ethanol we see as this like really cool bridge, but what's even cooler is the fact that this ethanol can come from all sorts of waste.
I've never heard about this approach before. And you really get me hooked on being a fan of ethanol now. The way you're selling it, it's really cool, and what you can make from it. It's so interesting. Basically, when you're talking about you're using waste, I think it's a little bit difficult to grasp of what, and especially when you talk about pollution, like how do you get the carbon out from just pollution? Can you somehow explain that a little bit?
It's a bit of a wild concept. And in fact, when we started coming up with it sort of almost 20 years ago, people thought we were kind of crazy going, well, this doesn't seem to make any sense. And pollution, it's very dirty. And traditionally, people use sort of thermocatalytic processes, which they need very clean, very pure input streams, because otherwise it will not work. But biology is like super cool. It takes chaos and creates order. So what we thought to do is, if I go back to that kind of brewery analogy, you can imagine retrofitting like a microbrewery into a source of these emissions. So a great example is like a steel mill. So today at a steel mill, they use carbon to reduce as a reducing agent in the steel making process. That carbon then is either combusted for heat or power, or it is just flared into the atmosphere. And we thought, well, wait, instead of burning that carbon, how about piping it into this brewery, and then our sort of biocatalyst or bacteria or microbe, whatever you want to call it, can eat the carbon in the gas. Now, there's kind of a bit more engineering and technology stuff that goes on in the middle. All the engineers are going, she's totally skipped the important part, which is basically how do you get gas, into where the microbe lives so it can consume it. And that's another story. We've cracked that. But essentially, you're piping the carbon from the chemistry of steelmaking into this brewery and then making the ethanol. So we don't need to, as I suppose with carbon capture technologies that we normally think about, is how do you get carbon out of the atmosphere? Because normally we think about emitting the carbon and then catching the carbon. But what we do is we catch it before it gets emitted.
Oh, okay. That makes sense. Oh, yeah. I remember you were saying something. I wrote this down because it was really interesting that you kind of call your approach more carbon prevention because you prevent it before it's going out.
We
That's
kind of
really
stopping
cool.
it. And when the technology is advanced, there are a lot of people working on something called direct air capture, taking CO2 from the atmosphere. It's kind of early stage now, but when that's advanced, we can absolutely use that carbon too. But for now, we think, well, why wait to emit it and then capture it? Why not capture it before it goes out? So that's our way of thinking. But we can take, carbon that is emitted and capture it there as well. And again, it's sort of a engineering technology there to sort of, again, pipe it into our sort of reactor, which is the brewery concept.
And who do you work together with? Like, do you have certain industry like steel companies that you're cooperating with that let you use their carbon waste, or how's that working? Like, how do you get the carbon? Because I guess from a legal perspective, who owns the carbon waste?
So what we do is we license the technology, and the steel industry is a really fascinating one because I'd say people don't think about the steel industry as like a very advanced, environmentally conscious industry. But actually they do it, thinking about sustainability in terms of continuation of business, cost, they do a lot of recycling. There's a lot of efficiencies within the steel industry. And so we actually work with a number of the largest steel makers in the world who are really interested in doing something else with that carbon. A lot of them in Europe, for example, they don't flare their carbon. They will make power, but they acknowledge that making power from carbon doesn't make sense. We've got more renewables coming on the grid. We want to do something else with it. And there's a special interest in looking at, well, what about making it into something like a sustainable aviation fuel? Because then you don't have to extract more carbon from the ground to make that fuel. So we work kind of, I suppose, upstream with those who have the carbon, and they depending on the arrangement we have with them, if we're licensing or how we're working together, they can get the benefits from that reduction, either through reducing their own emissions or selling it as a fuel. And then we work downstream because we kind of, I suppose we're like a matchmaker of working with a steel mill and an airline. Why would they ever kind of work together? Or a steel mill and a perfume company, but now the steel mill is making ingredients or inputs that another industry downstream wants. And so we are kind of connecting people, I suppose, creating an ecosystem around carbon recycling.
Carbon recycling, that's another word that you said, and I really like that. The word says recycling it's a cycle because you're reusing it. Is there a way that basically then the carbon you use to produce things, or I think that's where we can also move over to sustainable aviation fuels, because obviously when the fuel gets burned, then there's emissions again. Is there a way, like how often can that cycle be repeated? Are you able to reuse that again?
Yeah, and I think that will come when we have this, direct air capture technology and that has to really scale immensely to be able to take carbon out of the atmosphere. And so what an airline might be emitting, take that carbon and then turn that back into a fuel. So theoretically, absolutely, you could create this, endless cycle once you have direct air capture. And, when you use CO2, you need hydrogen. And to make a sustainable aviation fuel, according to a lot of current methodologies, you need a sustainable source of hydrogen. Mm-hmm. And the cost of that and the availability of that is quite challenging. And so I think it's a bit further away, but it's absolutely a sort of a theoretical goal for everybody to, you can start recycling whatever's available today, and ultimately we can capture that and have it back into a system. So it's a kind of a cool sort of concept, and ultimately limitless cycles once you get to that end state.
Okay, so right now it's because you're preventing it before it goes out. It's not really out there yet to then be reused.
Yeah, because today there isn't the scale of capturing carbon emissions from the planes that are flying everywhere. But if we were making something like a packaging, a sort of a solid material that could, so I'll give you an example, we could capture emissions from a steel mill, turn it into ethanol, turn that ethanol into PET to make packaging. That packaging could then be collected and goes through a process where it's superheated, and that turns it into a gas. So it's not incineration, it's not burning it, but it turns it into a gas. And we could put that gas back into the system, and then you could make ethanol, and then you could make something else. So you've got this, you have a concept to go circular. And, if it's something like PET, you can mechanically recycle it a couple of times. And then, mechanical recycling sometimes can be limiting because you can lose the properties of the material. But you could say mechanically recycle it a few times, then it goes back in, superheats, gas, ethanol, another product. And we kind of reset the clock on that. So it's kind of like carbon rehab, if you will, kind of start.
Okay. What I'm wondering about now is basically if the emissions never really happen, how does it work with the emissions counting in that case? So let's take the steel industry or like a company, and you are absorbing that carbon before it goes actually out as pollution. Do they then does that never really count as an emitted unit of carbon?
It's a really good question, and it's a really hard question because today, it's an easy question in the sense that you have to choose who gets the emissions credit. You can't count it everywhere. So if you're making a fuel like a sustainable aviation fuel, the methodologies that have been developed today for this type of fuel, which is called a recycled carbon fuel, say that, you can't count the emissions reductions for this fuel if you've counted it under something else, like an emissions trading scheme. So you have to make a choice. But the question then comes, and this is actually something that is under, I suppose, development discussion this year in the EU, especially on the ETS, the emissions trading scheme, is how do you give value across the whole supply chain? Because if the steel mill's getting no credit or has to choose one or the other, how are you ever going to incentivize this ecosystem? And so there are people who think, maybe you could split it. You're not going to double count it, that's a given, but maybe there can be mechanisms where there's a value across the supply chain, because you want to incentivize those with a carbon source, and you want to incentivize those who are meeting, say, mandates and targets and so on. But if you're only rewarding one, it's all going to come down to the value, and that could distort the system. So it's a very real question. Today there is, it's quite a defined way of looking at it, but I think there are maybe new ways that we could approach it to support further development across the supply chain.
It's so interesting. And then with the double count, or like the split counting.
Yes, yeah.
Is there any such thing already in place or somewhere in the world, or is that really just an idea?
No, I mean, this is sort of early stages of how we think about it, but it's definitely something that a lot of people are interested in, because ultimately, where are you going to get the carbon from? And while some regulations are prioritizing biogenic, this is talking about CO2 in the future. We don't want to just use one source. There's a lot of waste carbon, and I think it's all very well thinking about, well, there won't be any industrial carbon left after 2040. These are the kind of the EU goals, that there won't be point sources of carbon, so we're not going to incentivize that. This is another thing that is probably going to be discussed, because we have not advanced in our decarbonisation goals, globally, as much as has been hoped for. And so we can't just imagine that, for example, we're 2026 now, in the next 15 or so years, that we're going to completely change how we make steel or other metals, how we make cement, how we process materials. It's just unrealistic, especially when we think that to build a new facility for one type of processing technology can take 5 to 7 plus years. So it's not really grounded in reality to say that we're only going to use one type of CO2 that be biogenic. I think we need to have a pretty open way of approaching things to really hit the targets with as much as we can.
Talking about aviation, it's the sustainable aviation fuel that you can make from the ethanol. It's I think you said that it's not included in any of the SAF mandates as a mandatory target right now, right? As of for now,
using recycled carbon isn't as broadly accepted as other fuels. It is listed as a fuel that is allowed, especially in the EU regulations and UK SAF mandate. But in the EU, for example, there are not as many, I suppose, benefits for these types of fuels. And an example would be that an e-fuel, or what we call a renewable fuel of non-biological origin, a RFNBO, or PTL, they're all the same type of fuel. These are the fuels that use CO2 and green hydrogen. They can benefit from a kind of bridging scheme using ETS money to bridge the cost difference between fossil and the cost of that e-fuel. But a recycled carbon fuel is not allowed to participate in that. So there's kind of little barriers like that make it challenging, especially when, as a technology pathway, we have scaled this and, there is a viable path forward. But those who were perhaps earlier in the sort of technology readiness stage have these incentives but haven't actually moved as far ahead as we have.
Okay. Is LanzaTech the only producer of that type of carbon recycled, SAF?
There are others who are scaling. We are probably the ones who are furthest ahead, and we have a sort of a sister company, a company that was created back in 2020 called LanzaJet. And they are the ones scaling up the alcohol to jet pathway. And they have the world's first A to J plant in the US. So while there are others who offer an alcohol to jet pathway, the LanzaJet plant is the first. And that's super exciting to have it sort of, in the family, because as we know, the biggest part of cost for aviation, it's the feedstock and the fuel. And so if we can get, a low-cost feedstock for SAF, which could be waste-based ethanol, you create this kind of a nice way of meeting the goals that the industry has set itself.
When you're saying that it's not really supported yet, I've been talking before about a lot of the investment and financing barriers to SAF in general. And it's a lot of obviously investors hate risk. And if there's a new technology, they're not sure if it's gonna be successful, which is gonna be the cheapest in the future, all of that sort of stuff. So is that posing one of the biggest barriers for you to scale and attract investment as well? Or what are other barriers that you see?
Yeah, I think there's a couple of points here. I think there's one element which, sometimes I think about is that investors are maybe looking at these new technology pathways, and there's a lot of interest in them because there is that, it's still at the exciting dream stage. There's a lot of potential mapped out, but they haven't demonstrated it. These things really take time, and I kind of liken it to LanzaTech being the kind of, it's not the cute puppy in the pound, it's kind of the older scruffy dog that's been around the block, and we've scaled, we've got the technology, but we're now at the really gritty part, getting down the cost curve and proving it across geographies and, keeping the company going as we do this, and it takes time. Whereas other pathways, they have maybe not reached those TRL sort of levels, and they, there's a lot of exciting potential there, but they haven't built the infrastructure, they haven't got the plant built or steel in the ground. I think the other element is that you need, very robust, I'm trying to think the best way of saying it, for investors to reduce that risk on something like SAF, you want to have long-term offtake agreements. But airlines aren't always prepared to do that because that's not how they do things today. And so there's definitely an element of needing to work together as a sort of to adapt to these new market realities on how we can secure these robust offtake agreements, reduce the risk for investors and so on. The other element is that it really does take time. I mean, I think people often talk about permitting, but permitting takes a while, but also construction. So if you need people to be pretty patient as we're building, you're building plants, because you need the permitting and things in place to get to the final investment decision. And then you've got, alongside that, you've got detailed engineering, you've got construction, you've got all of these elements. It could be, 3 to 5 years waiting game to get to that beginning plant. And then you need to certify it and do the volumes and then transport your fuel to the, right place. And so there's a lot of, challenges that make doing this tough, unfortunately. But the money is there and the interest is there. And that to me is the really exciting thing.
How long have you been with LanzaTech? From the beginning, right?
Yes, since it started it started in 2005 and I joined in 2007. And I think I was like the fourth person. Yeah, coming up 20 years. I didn't quite expect to still be doing this now.
So that must be very exciting, I assume, like seeing how from such a small team and like an idea that you're kind of working on, you're really looking back now, looking at where you're now and where you were possible to develop and then attract investment and having the sister company, LanzaJet, having a whole plant. That must be something really exciting to see as well.
It is. I think when our CEO, Jennifer Holmgren, joined in 2010, and she's sort of known as the godmother of SAF because she worked on a lot of the original SAF technologies for Heifer and so on. And when she joined, she immediately saw the potential of waste carbon for the SAF market. And I remember going with her to the Paris Air Show, must be over 10 years ago, and we were in we had a little booth with Kathy, and it was really funny because we just had a little booth and we were talking about the concept, and then 2018 we did our first proving flight with Virgin Atlantic, and then a follow-up flight the following year with Al Nippon Airways. And then 2020 spinning out LanzaJet, which is doing amazingly well as well. And so, looking at it today, it seems unreal that we went from that kind of concept to really driving, continuing to drive the industry forward.
Is that also, it kind of leads over what I like to always jump into in the end of the conversations I'm having, talking about a future outlook. What are your optimism or pessimism and your hopes? So is that helping you as well, staying... Because I think sometimes it's easy to get lost in when you just look at this moment in time and you feel like nothing is moving forward. You're looking at the global geopolitics and everything seems almost against progression right now in that field. So I think literally your experience with LanzaTech over all these years and what you were just saying, is that helping you to then sometimes look back and looking at how far you've come, and so maybe we're still able to make it, to wing it?
Yeah, I think I like what you did there. Nice little pun. I think it's, it's hard, and I'm normally quite pessimistic because when we think about, I think there are some figures that say to get to where we need to go with whatever pathways you look at, you're going to need X many plants a year, and it just seems insurmountable. I think that the reality is, scaling SAF is not a technology story. It's a broader transition story. And I kind of touched upon that ecosystem concept earlier because, and I can use the analogy like streaming services. Today, we don't really watch TV channels that we might have done 20, 30 years ago. We watch all different streaming providers. But streaming only won when broadband, internet or whatever, 5G, whatever evolved. it only won when we all had our own device. It only won when licensing evolved. It didn't evolve in isolation. So just like for SAF only scales when you've got policy, when you've got airlines, infrastructure, feedstock alignment. And so while today it seems insurmountable, I think we're getting to a point where that ecosystem is becoming more solid. And that is what's going to move us forward, because the technology pathways are all there. They're sort of, it's not like conceptual. They're all doing their thing. We just need that broad, so as an example, on an ecosystem level, we need, CO2 infrastructure to catch up. We need, hydrogen infrastructure to catch up. Airports. It's a sort of industrial synergy that needs to happen. It's not just, if you think about one SAF project, it's not one SAF project. It's 4 to 5 industrial assets interlinked. And I think we're getting to a point where we understand that, and we see things moving to a point where we can all kind of interlink in a nice way.
I think I really like the idea of the ecosystem, because at Impact we actually talk a lot about this, because we see what you were just saying, that technologies are there, and oftentimes we do see a lot of people working on different parts of the problem and of different parts of the solution as well. It's very frustrating at one hand seeing that it's out there. Like, you speak to people like you and saying, okay, it's possible, but then somehow not really seeing how all these parts are working together. You were just mentioning infrastructure, and then the airlines, and then the investors that are still held back by certain risk, and the policy frameworks. Like, everything needs to come together, and we really oftentimes also talk about this ecosystem that really needs to be more interconnected, and I think getting together. I think that's also why we're really looking forward having you also speak at the Impact Forum, because we will have a lot of people from the ecosystem, from different parts there together discussing the different levers. But yeah, I think it's nice also to hear that you're saying that you're normally pessimistic more, but still you see that the solutions are there, and we can still get there somehow. Maybe not in the time that are written on paper and that we would and should need to. But I think it's still helping to hear that the technologies are there. One question that I'm curious about is, we have all these different SAF technologies. Do you think in the long term, and what you were saying, for example, right now HEFA is the most established, but in the long term, do you think there will always be a wide range of SAF technologies, or do you think eventually there has to be like one most successful that's going to be the established one?
I think it's very dangerous to just have one. Although, when I talk about A to J, it's interesting because it can use all the feedstocks of all the other pathways. So it's just like without the constraints. So A to J is like, magical. The other technology pathways have kind of picked the lane, and we kind of own the motorway. Or I should use a sky analogy, but it's the concept that I don't think it's going to be one pathway, but I think, unless you call using waste a pathway, but I think we have to get to a point where all the pathways leverage waste feedstocks because they're low cost. They are abundant. We don't want to create waste or have waste. We don't want to be incinerating it. We don't want to be burying it. And that it kind of goes for carbon as well. I mean, why do we want to bury carbon when it can be used again? Because I suppose when you're burying something or you're burning it, you still need to extract more for the things that you need. And so I don't think there's going to be really a point where we only use one technology, but I think we will probably get to a point where we generally only use technologies that can leverage wastes effectively. And I think the market will decide ultimately when we have scaled up the infrastructure for e-fuels, it is likely that they will end up being the leading one. But I don't think we'll lose all the others, because it will also depend on the geography and what's accessible in the region and so on. So you really want flexible pathways that can be distributed as well, not just one centralized location. Because as we're seeing today, geopolitical crises can cause, massive changes in the energy markets. So you don't want to rely on one pathway, one feedstock, one region. you want to have like a distributed network.
To me, it sounds like a win-win almost when we were just talking about it. And it's like, yeah, we don't want the waste and we can use it. So it actually, when you just think about it, it just makes sense. Why would we not want to scale that and have that as the ultimate goal to get there and be able to do that? Because, yeah, like I said, I think a win-win is really much describing it on point.
Yeah, absolutely. And if we get to a place where there's no waste, there's always other carbon, as we say, pivot to direct air capture, and you still need carbon in our lives. It's just how we, how we get it, what we do with it, and how we get rid of it is the key.
I think that's what is kind of making it also a little bit easier, or helping it to be optimistic or excited about the future, is really there's so many technologies that are still developing that can still happen. Direct air capture can be scaled and become better and be approved. So that can be, I think, helping having a good outlook.
You're back!
I'm back! So it's still recording. To everyone, I was gone for 5 minutes at least. I'll see in the editing if the rest of my said things is being recorded.
Okay.
But yeah, sorry about that. I mean, I'm glad that we reconnected. We were basically at the end of our conversation, I believe. But still, I'm glad that we can round it up and maybe have a last few words. First of all, me thanking you for joining and for keeping up with my technical difficulties.
No worries at all.
But yeah, thank you so much for telling me new insights about a completely new technology that's very exciting. And like you were saying, you're really doing a good job at selling it as cool, because it really sounds cool of what everything you can make with carbon recycling. And I'm really excited to see you also soon at our forum and hopefully find out more about that. And I think what I asked in the end was maybe also a very broad question on like, oh, what technology is gonna scale? But I think it's gonna be very interesting conversations with having people on the table that are actually working on these different technologies as well and are working on market activation, know much more about policy. So yeah, I think today's conversation was really helpful to get one more insight on one more angle of the whole SAF landscape, and I'm really grateful for that. Thank you, Freya.
No, thank you for having me on, and yeah, really looking forward to the end of the month when we get to chat with more people and to hear how others are doing, and hopefully with a lot of optimism as well.
Yes, of course. The ecosystem, basically, what we were just talking about, taking place in person.
Yeah.
So yeah, everyone that wants to find out more about LanzaTech and Freya's work, feel free to reach out to her. I'm taking the liberty to call up people to reach out if they have questions. And yeah, thank you and see you soon.
Yes, thanks so much, Leonie. Take care.
Thank you. You too. Bye-bye.